So this is part B in the titration curve. We're before the equivalence point. We know the volume of the titrant and we know the volume of the weak base. We're mixing two solutions together, so we have to do a dilution calculation. And the results of that dilution calculation are here in the initial row of the ice chart. So when you look at the amounts in a nice 1-to-1 ratio, the smaller number, in this case the acid, is our limiting reactant. So all of that gets consumed. So once you figure out all your equilibrium concentrations in this ice chart, next you want to identify what kind of chemicals you have. So we still have some weak base. We have its conjugate acid, and we have some bromide. Bromide is the conjugate of the strong acid hydrobromic, so bromide is neutral, and that means with our weak base and conjugate acid, we've created a buffer. So notice this is different than in the strong acid, strong base titration. We never made a buffer. When you have one component strong and one component weak, you can create a buffer because we're making the conjugate acid and we still have some of the conjugate base left over. So once you recognize that you have a buffer, you can go to the Henderson-Hasselbalch formula. We have to do a little bit of work with this because we need the Ka to calculate the pKa, and the Ka is for this conjugate acid. So our extra step to find Ka, we have to do Kw divided by Kb. The Kb value was given in the problem as 4.4 times 10 to the negative 4. So the Ka is 2.27 times 10 to the negative 11. If you take the negative log of that, you'll have the pKa, and the pKa works out to be 10.64. Then the other part of the Henderson-Hasselbalch, the base concentration is 0.0527, and the acid was 0.2368. And when we calculate this, we'll get an answer of 9.99. Notice we have more acid than we do base in this buffer, and so our pH will be lower than the pKa. If we had more base than acid, then the pH would have been higher than the pKa. Strong acid, strong acid, weak base, we can create a buffer. If we had a strong base titrating a weak acid, we could also create a buffer. We get a buffer when we haven't reached the equivalence point yet.